You're listening to EETimes on Air, and this is EETimes Current. I'm Taylor Marvin. Welcome to Brains and Machines, a deep dive into neuromorphic engineering and biologically inspired technology. In this episode, Neuronova's Alessandro Milazzi and Michele Mistella talk about the company's strategy and technology. Your hosts are Dr. Sunny Bains of University College London and Dr. Giulia D'Angelo of the Czech Technical University in Prague.
Welcome to Brains and Machines. I am Giulia D'Angelo.
And I'm Sunny Bains.
In today's episode, Sunny will be talking to Dr. Alessandro Milazzi and Dr. Michele Mistella, CEO and CTO respectively of Neuronova, a company they also co-founded. Their neuromorphic startup works in sub-microwatt edge computing. After the interview, we will be talking to Ralph Etienne-Cummings from Johns Hopkins University about the issues raised.
Thanks, Giulia. Neuronova is a very new company based in Milan, Italy, focused on immediate post-sensor processing. In this interview, we discuss how very low power can make a very big difference to the sustainability of many applications. This is particularly true where audio is important. We'll also talk about why they believe their technology is complementary to, rather than in competition with, some of the other neuromorphic companies in this area. There are links to both Michele and Alessandro's work and some of the specific papers we'll be discussing on our website. You can check them out at brainsandmachines.net. Alessandro and Michele, welcome to Brains and Machines. Can you start by explaining what you were doing before Neuronova? I know you were involved with building chips, partly at the University of Groningen, so talk to me about that period.
Yeah, sure. I can start. So from my side, I'm an electronic engineer, and after my master, I started to work in the R&D division of Micron Semiconductor into the Ticket Group. But after that, I started my PhD into neuromorphic computing. But I work mainly in system based on memory stores. So the use of memory store into neuromorphic systems. So I did my PhD on biological plausible use of memory stores into neuromorphic circuits.
On my side, though, I did a PhD indeed in Groningen, as you correctly say, Sunny. I'm also an electrical engineer. Actually, we come from the same university in Polytechnic of Milan. And there, with a very excellent group, we designed chips for a neuromorphic application, CMOS, and also a bit of memory sieve based. And that was very formative experience for us, for me, about how to design chips, what are the current challenges in the neuromorphic field, and what was missing in the landscape of neuromorphic chip that need to be, filled by somebody.
Why did you start the company, and what did you hope to achieve?
The starting point is that there is a lot of potential in neuromorphic computing. It's been around, it's like 30 years of researches. And now we see a lot of stuff that already done, but need the right channel to go into the market. Because as every research topic, it goes broader and broader. And now it's time to focus that into a technology, into a product that can be effective and impactful into the world. So the first point is the love for the field, I guess.
I agree with Alessandro. I think that the main thing we both found each other liking is the promise that neuromorphic has to deliver a perfect way of interacting with sensor, interacting with environment, with extremely low power, low latency, and these kind of things. And we decided to apply this paradigm to industrial use cases, so to places where actually there were people in need of specific applications. And that's what we found each other. So it's like, let's build something concrete that works, and we see from there.
And how old is Neuronova? When did you form, and how many people do you have now?
Well, the project, let's say, started more than 2 years ago, when we started to discuss, first of all, about the vision of the company. That was the positioning directly as a smart front end with the sensor. Then we started to play with the market because as a starting point, we was targeting industrial sensors. But we found out that's not the fit. So we moved more into consumer electronics. And as an incorporated company, Neuronova is born just July of the last year. So pretty young.
You're a baby.
Yeah.
And how many people are you now?
Currently, we are 10 people. So we grew a lot last year. We started as 3 co-founders, and then we started to hire people from labs and places we knew. And now we have a team of very brilliant engineers helping us.
Yeah, I just want to add that actually our average age in the company is 27. So we are young, but if you have a spot to focus competencies, to focus also the love for the field, we have now people that probably are the best experts because we spend time information. So we teach them a lot of stuff. That's really important because it's an investment also. For us, the first investment is on the people. And now we end up with people that are also better than us.
So can you talk through the kinds of applications that you're targeting and in particular why they need the kind of sub-microwatt power consumption that you're offering?
The first point that is needed to highlight is the capability of the sensors nowadays. So sensors are something that is really capillary in our society. There are a lot of trends like the smart cities, smart agriculture, connected devices, and IoT, where sensors are there. But sensors are measurements units, so they have not intelligence. The point is that we want a real perception of the physical world, and the real perception means always on. Always on, not just to measuring, but to extract information. That's why you need sub-microwatt power consumption, because there are a lot of functionalities, let's say, when you take a picture with your smart glasses that instantaneously drain more power than the single keyword spotting that is on. But that's just a frequency that is really low during the continuing use of the device, while the always on is still there and have a lot of impact on the battery draining of the devices. And moreover, I would like to add that's an enabler for the always on continuous monitoring on consumer electronics devices, but that's also an infrastructural problem. Because think about also Alexa, that is an always on functionality, you plug that into your house. But still, if you sum all the devices that are around the world, we are reaching the trillion sensor economy, and you have to sum up all the milliwatts. It rises into a high power consumption anyway. So that's not just a matter of implementing new functionalities into devices and make their battery life longer, but also to be sustainable into the infrastructure of computing.
And if I can add something, we noticed that indeed the main problem people are trying to solve nowadays, when you think about sensor, is the computation at the edge, meaning like you have a microcontroller that is doing some kind of matrix multiplication and you want to optimize it, right? But actually, that's not where most of the impact is. The impact is actually in the conversion between the real world and the digital worlds that are actually then being used to compute, right? So when you say that your matrix multiplicator or your accelerator consumes this amount of power, are you actually saying how much it costs you for the full pipeline to extract information? So we found actually that there was a missing point, and we saw that there was a market, we saw there is a need, we knew how to make it, so here we are.
That was something that Chris Tumazu coined as the analog shell, right? That point, that transferring from the physical world into the virtual world of the digital computer. So that's where you're positioned in that point after the sensor, but before the digitization process. That's interesting. So let's move on. As far as I can tell, based on the material you sent me, the TechCell chip, which is the one you did at Groningen, that chip was very kind of old school neuromorphic. And I mean that in the most positive way, right? So it uses spike timing dependent plasticity, STDP, and analog neurons with floating gates. Although the floating gates I know that you used are special, and we may talk about that in a minute. But in the material you sent me about Neuronova, you don't really say anything at all about the technology. So can you tell us more about what you're actually doing?
So indeed, we sent that paper because that was a bit inspirational, or like he showed us what you should do and what you shouldn't do about the technology of neuromorphic. We are indeed, as you defined it, old school neuromorphic. We still think that the initial paradigm was a way to go, of course, for some things like the analog part, like the usage of synapses with memories and this kind of stuff, because that's actually where you really achieve low power and some level of computation. So we started from there indeed, but then we added more on the software part, on how you can circumvent the problems related with analog using the powerful tool we have nowadays, like training and these kind of things. So this is the base of what we do, what we improved in that sense, and more other things like trying to focus more on the device can actually work in several conditions with a lot of mismatch and all these kind of things.
So one of the things that I'm still not clear about is whether in your hardware you are using floating gates or memristors. I know that in the documentation about the TechCell chip, it was always sort of said that the floating gates were really just placeholders for memristors that you thought were coming. I was actually just at a memristor conference here in Edinburgh a few weeks ago. I know that there are now commercial processes where you can get memristors done. So can you tell us, are you using memristors or floating gates?
Let's say that memristor as a technology has a lot of potential, for sure, especially when you need the dynamical memory element. To explore the dynamics of the memristor element, for sure they have also a lot of scaling capabilities that actually can help in the direction of keep scaling the technology. Our approach at the moment is to use the bricks that we already have that are more reliable, because there are a lot of variables when you build a company, and especially in the technology part, that you want to be really, really reliable. So we don't need at the moment memristor. We are purely CMOS based. It's non-volatile memories that we have available with our foundry, and that's perfectly fine at the moment. So you have to push down your enthusiasm about technology in order to have something that is deliverable then. So we prefer to have something deliverable than an amazing technology that integrates a lot of stuff, but then it's just an exercise.
Also, something that is paramount in the semiconductor world is the supply chain, right? So if you're building a company based on semiconductors, you want that the things you do are actually not very super related to a specific player or a specific technology. And with memristor, I mean, there are some potential technologies coming up, but it's still very early in the adoption. So you want a supply chain that is stable, and that's another point to take.
If it's not floating gates and it's not memristors, what are you using for your non-volatile memory?
Then it's floating gates, just a fancy floating gate if you want. So it's the one that you can find in most technologies.
So can you talk about the advantages and disadvantages of using STDP in your systems?
We are not actually using STDP, so that was indeed TechCell. We are not using any STDP nor any local-based learning rules. We have a mixed approach between training offline and then a bit of fine-tuning or calibration, let's say, directly on-premise. The STDP, though, is a cool technology, but it's difficult to implement, and especially on the software side, it's very complex. Like, you don't really get much trained with this kind of technology. So we use normal training methods.
And just so that I understand correctly, so you're doing most of your training offline first, using presumably some kind of backpropagation. And then once you're ready to deploy, you do some maybe kind of calibration to the specific circumstances in which the device is going to live. And then you freeze it. Is that right?
You can actually continuously change them with a given interval inside the chip. So even like you can update some weights during the life of the chip.
Without communication with the outside world? I mean, is that an internal function or is that something that's triggered externally?
It's intended to be internal. At the moment, it's external.
Great. So forgive a naive question, but you say your chip recognizes 90% of Google's speech commands. Is that on the 12-word or 35-word vocabulary?
Actually, we did the test on 10 words that are not related to the numbers, but the commands. Because again, for us, what is really important is not to beat benchmarks, but to enable functionalities. So we found out that that's enough. We can push them to do more classes, but actually that was not the point. So we are just really focused on what is needed by our partners and customers.
And presumably the performance that you get is sufficient for the applications that you're targeting.
Yeah, the crucial point now is there is a huge market for, we can say, low number of classes inference, and we are exploring that. So first of all, we are exploring the classification of signals from sensors, and there are a lot of applications, as you can imagine, from the wake word detection, keyword spotting. Wake word is just two classes, the right word and the wrong word. That's also true for all the, let's say, anomaly detection tasks. If you have ACG, AKG, and you want to detect specific anomalies, that's still, again, a classification. So usually you don't need for our target to have a broad range of classes, but you want some specific task. Also because the approach is, again, sensing the real world, and usually you don't need to extract a lot of information. If you need the brute force, you can wake up the central system to process your information with the extended computational capabilities if you need a lot of classes, if you need to run your LLM locally. But for our positioning, that's enough.
Okay, great. So one of the things is you compare your own performance with that of Sentient, who you say get 140 microwatts, if I remember correctly, something like that, compared to your less than 1 microwatt. So there are a lot of different companies that are working in this space of small, relatively low power, smart sensing based processing. Now, I have two questions for you. One is about when we talked previously, you mentioned that you thought you were complementary with processors like BrainChip and Inotera, and we'll get to that. So Sentient, you see as more being a direct competitor. So can you talk about, first of all, that kind of segmentation of the market in these low power processors? Because I think a lot of people are a bit confused about that and where the different points are on that line.
Absolutely. The first question is for all the technology. Are you after or before the analog to digital conversion? So are you dealing with digital technology? Are you dealing with a mixed approach or analog approach? Actually, that's a technological limitation. If you have to deal with digital technologies, you have a floor and you cannot go down. So if you want to go down with the power consumption, you need to move analog. So for example, a company that is working in that field, I don't know them really well, but they are analog, is for example, Aspinity. Aspinity is going lower with the power consumption thanks to the analog approach, but they are targeting, let's say, a different degree of intelligence. Okay. The example can be related to the speech. They can detect if someone is speaking. We can detect what are you actually saying. So that's a different story. So what we observe is that we are moving on a real clear trajectory for the actual hardware landscape. That is, the more intelligence you want, the more power you have to drain, but still moving on that straight line. We are breaking that line thanks to the combination of the analog approach, the neuromorphic, so let's say the sparsity, so the use of spiky neural networks, and then also a lot of time spent with the software stack, the right positioning into the problem, into the pipeline, because there are different pipelines for different devices. For example, to come back into Sentient, they can be perfect for a specific market, while we can be perfect for another segment. As we said, we are going into the trillion sensor economy, but we cannot pretend to find the same model, the same technology for all the application. And that's a bit the problem that we had with the last century in computing systems. We had the von Neumann approach to hold the computing systems, and we keep pushing that. That's fine. But we realize today that we need a new paradigm like neuromorphic, like quantum computing, like in-memory computing, that needs to address all the needs of a society that is always more mixed, with more complex data, with different type of data. Because if you have to deal with calculation, perfect, you can use valves and the tubes and so on to make that. But when the things start to evolve, the society starts to evolve, you need new infrastructures.
Also, if I may add a rule of thumb for differentiating in our vision about like a different level of low power consumption and different level of microchip for this, I would say that the main thing can be that how much do you consume when your thing is off? I think that's the main deal breaker. Because, of course, if you do a lot of computing all the time, then the amount that you consume when you don't do anything is meaningless. Like, why would you care if you keep computing? As soon as the GPU doesn't work, it's wasted money, right? While in the case of very edge, you do want really to value how much you consume when you don't do anything. And so we see there the main differentiation of what we do with respect to what other companies in the sector do. Because that's really what puts you before or after the ADC. Because you can wake up the other components because you are the one consuming very low and they are consuming more.
So talk about that complementarity then. Are you actually looking at trying to be part of a food chain of going from sort of a neuromorphic signal conditioning to neuromorphic processing with Initerra or SynSense or one of these companies? Have you looked at that? Are you putting packages together that way?
Well, actually, we are not directly collaborating with startups and scale-ups because the level of interaction, for sure we interact with them, is about spreading of information, trends of the market, and so on. But on the business side, for us today is important to collaborate with the standard providers. So big corps that are actually active into the segments of microcontroller, first of all. So the complementary approach, and it's a synergistic approach, is well fitted, but now the point is to be complementary with the standard systems. And for sure, there can be a lot of synergies also with SynSense and Initerra as well.
Where exactly are you in your business cycle? So are you just sending out evaluation kits? Are you close to shipping real product? Talk to me about where you are commercially.
Yeah, actually, we opened the pre-order of our evaluation kit that will ship at the start of next year. Now there are two sides, let's say. The first side is again the love for the field. So we love to be engaged also with the universities to start to play with our technology and see that there is space for neuromorphic computing, still a lot of work to do. Also, you can build on an infrastructure. Okay, you don't need to reinvent again the infrastructure. And on the other side, we are targeting the shipping with the specific strategic partners that we already have. And so the next step will be design in. Actually, we already started with some design in, but it was a bit early in the roadmap because the plan was in 26 working into the design in of specific products. So in the consumer electronics, in order to be in 27, 28 with the ships into millions of volume units into that first products.
So can you talk about in that space, what are the applications you're most excited about and why?
It's the audio market because the audio is the new way to interact with the technology. We are tired to be in front of a screen all the time. So that's really a game changer way to interact with the technology. And still, we need an always on infrastructure to address that. So we are really excited about the audio, both for the vision and also for the commercial traction, because that's also the important side. So we are really, really focused there now. But again, with the same platform that we developed, we are also scouting something into the health monitoring. So health monitoring is another segment that we like a lot because, again, It's an always-on functionality. You don't want to lose data there, and you want to be really capillary on all the type of variables that you have to monitor. And then it's also a matter of being the enabler of a new future. Also think about wearables actually now are their devices on your arm, but they can be integrated into dresses. Okay, if you can make them with a small form factor, with a cost effectiveness, you can enable a lot of models. You can see a lot of scenarios where that technology can be framed.
I wasn't clear. You were talking about strategic partners. Do you have any contracts yet?
Yeah, we can say that we are 1 year old, but we will close the year with almost 250,000 euros of revenues. That's not selling the chips, but selling the value of our technology. So the point, as I always say, we could close the year with the 1 million of revenues, but that will be at the cost of spreading the focus of the company. So there will be no revenues anymore. So not the best story. The revenues are just not a real metrics in my opinion, but it's still a message about there is an interest, there is a commitment for our partners. So we are building strong relationships. That's the crucial point for us. Because when you have to make a product and you are a cheap company, the integration is a story that you need to learn. So we are really focusing on who has a clear vision and a clear product roadmap. About the names, obviously we are under NDA, but actually we are working with people that, let's say, are around us. They are in our pockets and devices that we have around. So they are big corp. Our approach, due to the business model and so on, is also few big. So few companies that can generate big revenues, but that's not because we are targeting that, but for the sustainability of the company, for the integration of the model. And to come back again within Atera, Sinsens, and all the other startups that are active in the ecosystem, they are really good for exchange of information, learn a lot of things together, but to be sustainable, we need to reach high volumes in that market, and that's the first target.
You mentioned biomedical sensors. So I'm assuming that you are mostly looking at some kind of wearable sensors, sort of external body sensors, because I know that there's a lot of drift and problems that happen when you do implantables, and also it takes a lot of regulatory time and energy to get those through. On the other hand, you could be really good for implants because you don't have to replace the batteries. And potentially, from what you said, you could compensate for the drift that happens in this hostile environment inside the body. So do you think you could be inside the body in 5 years, 10 years? And what are you looking at right now in terms of biomedical?
I think that actually the technology that we are building could be in a lot of things. We talk with a lot of companies and we see that there is indeed a very huge demand for this kind of technology, ultra low power, under microwatt, even without batteries, these kind of things. It's something that a lot of people need. They don't need the very complex task, maybe they need the rather simple ones. But of course, we are a startup and we are very focused on building a product, going to the market and prove that our technology works in the serious people business. So of course, the kind of technologies that require a lot of certification will be something that we will tackle after, or like in a slower way, just because we need to, survive or at least sell something. Focus.
We are actually working as a subcontractor with a Swiss-based company exactly on that. They do neural prostheses with organoids that are implantable biological systems that if, for example, if you damage an area in your brain or an area in your spine, they can represent the connectivity. There is just a problem that organoids are stupid. They don't know what they have to do actually. So an electronic inside can give them the right degree of intelligence. And we are working as subcontractors, so they are developing all the stuff in that segment because actually we are the only technology that can fit in that biological system because that's really bioinspired, the range of current into the game, are really similar with biological neurons. So that's the perfect interface also for biological applications. So that's for sure another market. Again, we come back to the story of before. There is a lot of spread for IoT, for monitoring. We have industrial, we have a lot of interest on a lot of sites, but we need to focus, and that's the main goal.
Beyond the immediate prospects for Neuronova itself, what do you predict as the future for neuromorphic engineering?
I think that neuromorphic engineering, as it always has been, will move into more directions than one, and everyone will get a different name or end up in a different other field, as it always happened, like DVS camera. They started neuromorphic, now they are just cameras. So they now move in vision or like cochlear cases or this kind of thing. So I think that there will be a different direction that it will take. There will be the sensory part. That's the one we are tackling, where ultra low power, probably under the nano, under the pico, will be something that will become more and more present. But on the other side, also, all the knowledge about sparsity and this kind of thing will be leveraged for moving closer to the GPU or something like this, like Spin Cloud is doing, or these kind of companies where a neuromorphic, of course, a different paradigm of neuromorphic, I would say, could be beneficial for this. So I guess that in university, you will learn at the analog class about the analog neuromorphic, and then in the digital class or in the HPC class about, the digital neuromorphic or the high compute, the big computer neuromorphic. So I think you will see more and more these two paradigms because they are coming. We see application, we see people that are doing those. So that's my forecast.
Yeah, I totally agree. We had exactly a few days ago also a discussion with Samit, the CEO of Inatera, about that neuromorphic computing is a great paradigm, a lot of lessons learned that need to be focused. It's a huge spectrum, and we are positioning in a specific segment, but a lot of other companies are positioning on different side of that, and that's amazing because a lot of work has been done, and there is a lot of potential to bring into the market.
Alessandro and Michele from Neuronova, thank you so much for coming on to Brains and Machines.
Thank you very much.
you.
It's been a pleasure.
Thank you, Sammy. So with this interview, I can definitely say long live neuromorphic. For more about Neuronova's work, please go to brainsandmachines.net. And now we welcome back our regular commentator, Professor Ralph Etienne-Cummings from Johns Hopkins University.
Hi, guys. How are you doing? Very nice to be back with you.
Hi, guys. So, there's lots of pride in this interview. I'm not going to lie, but let's try to start with the first question. So they talked about the channel in the market, what they are doing, and audio is the new way to interact with technology. And Alessandro was saying we are tired of being in front of screens. And I definitely agree. The wake word detection is a very good place to start, but also Sinsens and Inatera already tried to tackle the same problem. What do you think? Do you agree with this market decision?
I think it's an interesting perspective that they present, right? At the end of the day, they're basically saying that they found a niche in the market. They found a place where there was a need, and they have the hardware that could take it down to 1 microwatt, and that is the keyword spotting and always-on technologies in the audio space. Yes, there are other players, but I've never been one to think that just because there are other players in the market that somehow that makes your approach not viable and not good enough to compete. I think it's a good thing. I think it's good to see other players entering the market.
Yeah, they did say that they felt that their technology was complementary rather than competing with some of these other approaches. I know that they see themselves as having a niche that's not being looked at by anyone, this sort of pre-processor, smart front end or whatever it is that they call what they're doing, which is a little bit different than the processing I think that some of the others are doing. And it is very low power.
And the fact that it's all analog is the other big deal, right?
Yeah.
Most folks would go into the digital space, so they ADD convert, and then do all the smart detection and word spotting and so on. They claim to be doing it all in the analog space. That puts them among very few people. There are a couple of companies out there, and their names are escaping. I think one is called Blue Mind. And then there's another one out of Canada as well that I'm blanking on right now. But
BlueMind is a company that we've actually been talking to get on the podcast. There's another one called, I'm actually not 100% sure how to pronounce it, but it's spelled Polyn. And we were talking to them about being on the podcast, but they're very secretive about their secret sauce. And I didn't think it was going to make a super interesting episode at this moment until they're willing to be a little bit more forthcoming about what they're doing. They're also working, incidentally, all in analog, but they're working at a slightly higher level. So they're working with bigger systems. The Neuronova work is very neuromorphic focused, right? These guys come from a sort of very Giacomo, Elisabetta Kika, old school neuromorphic pedigree. And I think what they're doing reflects that, as opposed to this Paulian stuff, which was much more sort of matrix multiplication, but doing it in analog so that you're getting power benefits from it.
That's actually really cool. So I think that they stand a lot and they're very brave to come into the market with something fully analog and bringing the power consumption so low. It's impressive. And I also loved that Alessandro underlined that in this century, the von Neumann architecture dominated the market, right? But we have now different ways of computing and we need to push that. I agree 100% with him. But my question would be, let's say the market is becoming warmer and warmer, let's say like more companies are joining. Like I found out a company, Neuromorphica, in Bulgaria randomly the other day. So what I'm trying to understand is, do you think that they will all find some specific niche or they will battle at some point? Because I understand the niche of Neuronova is perfectly clear, is analog and very low power, like even more than classical neuromorphic. But what do we do with all of these companies?
so it's neuromorphic, it's analog, it's speech. So those are the pieces that they are saying that they're doing. That's Neuronova. And again, I don't see why another one cannot do that. I might do it slightly differently than what they're doing, and somebody else might do it slightly differently yet again. So it's okay for that. Yes, they will compete. And competing is not a bad thing either, right? It brings out the best of us. So I think that's all good. These are all the things that are going to make neuromorphic more viable in the long term. The other thing about it is that I think that at the end of the day, we are still developing technologies, right? We're not at the solution yet. Yes, these guys are saying that they might be shipping millions of parts next year, I think is what they said. But that's still at the very infancy of applications in the real world. So this is good. And I love the fact that there are so many folks doing neuromorphics differently. You know where I come from there, right? So this to me is speaking my language.
Absolutely, absolutely. But actually, I think the person to answer your question, Giulia, is not necessarily among us, because one way or another, we're all academics. The person who I'd actually like to hear from, and I'm going to use our discussion now as an excuse to send her an email and ask her. There's a woman called Sally Ward-Foxton, who EETimes readers will know well, who writes a lot about the AI chip space, not just neuromorphic, but including neuromorphic. She, for instance, I believe has written or was in the process of doing something more with applied brain research, which is Chris Elias-Smith's company. Chris Elias-Smith having been our last episode. So what I'm thinking is maybe we should get her on and have her talk about what she sees the different segments as being, having a much broader view of the AI business and the AI chip business than any of us do.
Yeah, that would be an amazing idea. So another thing that I'd like to say is that the company is based in Milan, in Italy, and I can't be prouder, because starting a company is not a joke, and starting the company in Italy is even more difficult, let me tell you. So I'm very proud, and I need to thank them. So they also said that they are intrigued by health monitoring application, again, smart choice, wearable and medical devices. But then here I have a question for Ralph, since I know that you are around that space. I'd like to know, what do you think is the realistic today application in that topic?
There's a couple of things that one can look at, right? There's the stuff that all the big boys have been doing. I mean, when I big boys, I mean Apple's and Samsung and so on, which are all the smart watches, looking at trying to understand what your hearts are doing, trying to understand how your blood oxygenation levels are, and then trying to do something about predicting your health conditions. So those are realistic. People use them. My wife swears by her Oura Ring. She looks at it and tracks her stress up and down and whatnot. So folks are actually using that. Now, I care more about something that's a little bit closer to the clinic, right? So where I want to know something like, are you on the pathway towards a stroke because your blood pressure is spiking every time you stand up? Those kinds of things are not currently being monitored by doctors. Remember, like when you go get your blood pressure measured at the hospital, what they do? They make you sit down, they say, relax, they stick the cuff on, and you're not supposed to be moving. Well, in those conditions, you don't see those unusual spikes that might actually lead to a stroke event, right? So that's where I think wearables will be extremely functional, extremely useful, and will provide so much data to the health practitioner to be able to determine the health of the individual.
So there's one thing that I want to add here. There is a nice company, Axite, where both CEO and CTO are women, so just nice to mention it. So they couple the EEG with the typing that we do on our phone, and they can detect if you're about to have some sorts of seizures or you are about to have some problems. But now I'm going to ask you a question that is not strictly technical. How do you tell 30 minutes before you're having a stroke to a person that it's about to have a stroke to go to the hospital? That's one of the hardest problem, I think, in this market, because the person is going to have an heart attack instead in that very moment. So that's a very teeny tiny problem. Even if you solve the problem, how are you going to communicate something like that? They are doing it amazingly, by the way, but that's an interesting question to ask.
So the answer to it somewhat is the notion of the hospital at home, right? Where even though you are not in the ward, all your data is being streamed, is being collected. The decisions that your sensors are telling you or the wearables are telling you, all those things are also being streamed to healthcare providers. So in the event that it looks like, hey man, something really real is going to happen, you're going to get a call from your healthcare provider. You're going to get a dispatch of an ambulance, whatever the case may be, what's needed. Of course, these are still very much in their infancy, right? The whole hospital at home business, it's very much on the purview of the big hospitals around the world, but it just has not happened yet. But that's where I think is that connection between the logistics of moving people and the logistics of getting information to your healthcare provider and then looping that all together is what's going to make it work.
This is going to go into a little flight of fancy for a minute, but just bear with me. So there was a book I read. I don't read a huge amount of science fiction. I watch more than I read, but I read Neil Stephenson's book, The Diamond Age, which was about nanotechnology. And he had this idea of a book that would be a tutor for rich kids, right? And the book would essentially show you actors who were being your tutors coming through the book, but it would all be done remotely. And then the next phase of that was they couldn't afford actors for giving these books to ordinary people. So they ended up making them essentially with some science fiction version of AI at the time. You know, this was like 20 years ago, I think, or more, this book came out. But what this makes me think of is that what we will end up having is that it won't be the big hospitals. It will be AI companies and the companies that actually are selling Oura Rings, that are selling Apple Watches, or services that grow up around them, where they will have AI that is tracking what is going on with your health. And they are the ones who are sending you the messages saying you need to get your blood sugar up, or you need to sit down now, or you need to get to your nearest hospital right away. I have the National Health Service to look after me, so I'm lucky. But for those people who don't have free health care, I think that's going to be one of the ways that AI and these devices are going to help.
Yeah, and I think even along the same path that you're talking about, maybe they're not the ones who provide the actual intervention in the end, but they are the ones that communicate to the physicians at the hospitals and so on and so forth. So this becomes now a new business model, right? That middleware that links between the person at home and the hospital and that's your AI system.
One other thing that I'd like to add is that I was recently in Iris in China, and I think that our society is not as ready as they are to include technology in our lives. Like I really have seen robots doing many different things and people are okay with it. I can't imagine the, let's say, American, European folks giving their prints everywhere or taking pictures everywhere to open doors and things like that. So I think that we need also to train the society to use the technology in general, right? It's a big deal.
Yeah, it's a culture, right? I mean, that's kind of the last inch. You create all the technology all along the way, and then to get people to use it, you have to change cultures, which is really what's difficult.
Which is the same shift of paradigm that we need to push with neuromorphic computing. We need to train.
Oh, yes, guys, just a couple of things I want to say before we finish. So I really like the fact that they were talking about, as you referred to it, the analog shell, coined by Chris Tomaso. But I also think that they are broaching on something that I've been trying to get into the vernacular, which is the sparsity shell, right? Which is what's being generated by these systems is a lot of data, right? But you cannot deal with it all. So how do you deal with sparsity? What is salient to the problem at hand? How do you compute that saliency, and how do you only keep relevant data? And all of that is also going to be part of the job of these sensors, and to do it at microwatt power burn would be very useful, right? Because if they're going to be on the entire time, you can just imagine just how much data is being collected before it becomes information even. So that I think is a nice aspect of what they talked about. Then the last thing that they talked about, which I thought was a little bit more talking about the flight of fancy, which was this whole notion of connecting organoids into brains and then having some of their chips somehow being involved in that whole entire system. So as you know, Sunny, I'm a big fan of this, but it's quite a ways from a commercializable application of their technology.
I have to say, although I'm not allowed to share it, they did tell me who they were working with. So they are genuinely working with another company. So we'll have to see how that develops.
Okay, guys, I think we can stop here. Thank you so much, Sunny, for yet another great interview, and Ralph for your comments as usual. In the next episode, Sunny will talk to Rodolphe Sepulcre from the University of Cambridge about control theory and neuromorphic engineering. We hope you will join us then.
That brings another episode of EETimes Current to its end. Thank you for listening, and thanks again to our guests Alessandro Milazzi and Michele Mastella of Neuronova. EETimes Current is available through all the major podcast platforms, but if you get to us at our website at eetimes.com, you'll find the transcript along with direct links to the other stories we've mentioned and other resources. Thanks for listening.